Welcome to Scrap Paper and Philosophy 12. Today I have a fascinating thought experiment because we're going to show how two positive charges and two negative charges can form the ingredients to a spinning magnet. Or, well, I am not prepared to think of these four quantities as a hydrogen molecule, although maybe they are a hydrogen molecule if you think of two protons and two electrons. But we're not going to go there. We're just going to try to figure out how they can assemble into a spinning magnet. So we're going to start with this picture on the left. Here we have a positive which went flying into a negative because they experienced the force of attraction, the electrostatic Coulomb force of attraction. And when they hit each other, what they really wanted to do is this plus wants to occupy the space of this negative, and this negative wants to occupy the space of this plus. And they cannot do that because of some exclusion principle or some countervailing force that we interpret as a Planck volume surrounding, embodying these charges. Whatever the case may be, okay, they want to occupy each other's position. They can't, but they can do the next best thing. See, now the positive is really occupying the position of the negative, and the negative is really occupying the position of the positive. Except that they're still experiencing this overwhelming force, and now the positive wants to occupy the position of the negative, and the negative wants to occupy the position of the positive. And this is how they do it. Now, because we have some kind of angular momentum going, we're going to assume that this goes always in the same direction, like this. Now, let me backtrack a little bit, because we really have four modes of spin here. This can go counterclockwise like this, or they can spin clockwise like that, or they can spin into the page, or they can spin out of the page. So we have four modes of spin. But let's assume, just for the sake of argument, because what we're going to show is a spinning magnet, how to assemble a spinning magnet, and it'll be enough to just assume that they chose this way of spinning out of the four possible ways of spinning. So what we're looking at here is a circular current. We're looking at a circular flow of charge. You see, if we imagine, of course, the circle, if we imagine the center of this charge and then the center of this charge, and then we imagine like a circumference like this, which the center of these two charges might be moving along. So we have the circular charge. Well, from the circular charge comes a magnet. The magnet, the circular charge, the circular current, I meant, because, I mean, there's no such thing as circular charge, right? But there is such a thing as circular current. So we're looking at a magnet. And right-hand rule, let's assume there's a right-hand rule thing going on here. So we have the north pole of this magnet going out of the page, out of the screen, if you will, and the south pole of this magnet going into the screen. Now, for some reason, let's assume that the same thing happened to these two charges. They could have chosen any one of the four modes of spinning, clockwise, counterclockwise, into the page and out of the page, but they chose this one. They chose the same sort of deal. So we have the same sort of magnet. We have a magnet with a plus, with a north out of the screen and the south into the screen. Now, what we're going to do when we align these two, one on top of the other, is that, remember, the north is going out of the screen and the south is into the screen. So the north, this north, same deal, it's going to go out of the screen. So it's going to align with the south. You see, the north, the north and the south are going to align because we're going to have them stacked. So one on top of the other. So the north goes out, the south goes in. It coincides with the north from the other one. And we know that north and south poles attract. So what's going to happen is this spins and as that spins. Well, what does happen? We know that the two magnets align. But do they spin? Now, let's look at a very interesting property. Let's assume that one of them is actually spinning clockwise and the other spinning counterclockwise. What's going to happen there is that the south pole is going to align with the south pole, or vice versa. The north pole is going to align with the north pole. And these two magnets are going to go flying apart. And as they go flying apart, what's going to happen is that one spinning system is going to try to unspin the other spinning system. So we're going to have a cancellation of spin. Okay? But as long as both are spinning in the same direction, like this and like this, we're going to have a reinforcement of spin because we're going to have the magnetic attraction between the two poles. Now, the way that we're going to envision this reinforcement of spin is that this plus is going to want to eat up the space of the minus behind it. And this minus is going to want to eat up the space of the plus behind it. And that's going to happen at the same time as this minus is trying to eat the space of this plus, and this plus is going to try to eat the space of this minus. So we're still going to have the spin, but on top of the spin, we're going to have this plus trying to eat the space of a minus behind it. We're going to have this minus trying to eat the space of a plus behind it. And how that's going to work out is the spinning magnet. So there we go. We have a spinning magnet from 4 elementary particles, 2 positive and 2 negative. Now, what I'm going to do next is kind of off topic, but just for the sake of physics, we're going to juxtapose this with an actual classical electromagnetic wave being generated inside an inductor. So I'll do that in a second. Thank you. Okay. Okay, so before I move on to the next topic, let me just, which is this circuit right here. Let me just, I mean, if you're an electrical engineer, just you should already imagine just by looking at this circuit where I'm going with this. But if you're not, just hang on. Uh, I forgot to mention. I said something about four modes of spin here, and actually, there's infinitely many because if you think about it, for example, this picture, when we spin this on top of the other spinning picture, well, suppose the other spinning picture is 10 degrees misaligned. I mean, right now they're perfectly parallel. Consider that 0 degrees. Now spin the back picture 10 degrees off screen so that they're misaligned. And what you're going to see happening next is they're going to spontaneously go into alignment because the tendency is for the North Pole to align with the South Pole. Remember the magnets? So with that tendency, they will align. And then with the tendency of one picture to want to occupy the space of the back picture and the back picture to occupy the space of the front picture, then you get the spinning magnet, which is a complete magnet, right, made of both submagnets. So anyway, let's see, maybe maximize this. And here we have the circuits to generate the electromagnetic wave. And what I want you to imagine is that we charged this capacitor with a power source, but because we have little resistance in the circuit, we're not going to worry about, we're just going to disconnect it from the power source, and we're just going to let the circuit passively do whatever it's going to do. So first we imagine that this inductor is, by the way, this inductor is a coil of wire, right? An inductor looks like exactly like a coil of wire. So we're going to assume that this coil of wire is not there. And what's going to happen is that the current is going to flow all the way until these charges here have not accumulated anymore in the capacitor. So until there's no more electric field across this open circuit here, which is really a capacitor, in the sense of two plates facing each other. Now, let's repeat the exercise, but with the coil. So what's happening here is that the current is really emptying out, just like when the coil wasn't there, and this was just a closed circuit. But now it's spinning around, spinning around, spinning around, spinning around, spinning around, spinning around, and it's going to start spinning faster and faster as the current increases. Eventually, there's not going to be any electric field here. But what's going to happen is that the circuit is going to overshoot, and it's going to build an electric field the other way. So these minuses are going to become pluses, and these pluses are going to become minuses. Okay? But I want you to imagine, okay, why is this inductor overshooting? And it has to do with the fact that these charges are spinning. Because once these charges are spinning, what we call this, by the way, is simply a magnet right in the middle of this contraption. So we can have a magnet like this, North Pole, or facing down, that like that, the North Pole, and that way, and the South Pole that way. So we call this an induced magnetic field right there, right? But the point is, once the charge in the capacitor is down to zero, or I should say the voltage across the capacitor maybe is down to zero. Uh, Same difference. So when that happens, okay, this spinning charge is still going to be spinning, and that's going to be dragging the charge behind it, and that's going to have a you see the the spinning charge, it wants to make the charge on the adjacent loop spin because it's moving and it's exerting forces on the adjacent loop. So it's this spin really of the charge that is driving this current to go past the neutral point on the capacitor, and making it build charges the other way. And then, of course, because this is a circuit to generate an electromagnetic wave, we assume that this is going to oscillate back and forth. And effectively, this oscillation is a train of north and south poles, if you think of the magnetic field, traveling to the antenna. And every two of these is 360 degrees spin of a magnet. That's what I'm trying to drive home. So this circuit is blowing out, this antenna is blowing out electromagnetic waves as if they were bubbles, stationary objects. Perhaps it's the circuit that's moving with respect to vacuum. Thank you.